Good morning. Today we're going to do section 4.6, which is solve exponential and logarithmic equations. So we're going to actually use some of these log properties and our exponent properties to solve some equations for x. So we have this property of equality for exponential equations that we're going to use today. I'm only going to do this first example today. We're just going to do this in 3 parts. So it's pretty straightforward, but it says if you have the same base, that you can just set the exponents equal. So the trick today is that we are going to try and make our bases of these problems look the same. So if you look at part A, we have 4x as the one side of our equation and 1/2 x minus 3 is the other half. So how do we make these bases equal? Well, this gets back down to our exponent rules then. It should be pretty straightforward. You do have to use parentheses here. Make sure you're using these. When you rewrite these bases, you put your parenthesis and your old exponent needs to go on the outside. Okay, so we're going to do that for both of these. And then let's think, how do we rewrite 4? How do we break that into the simplest exponent as we can? Well, that would be 2 squared. Okay, and that one's pretty straightforward. How do you write 1/2 as a power of, or with a base of 2? Well, that would be 2 to the negative 1. Okay, so we've rewritten this. Now we need to use our properties of exponents, which say when you raise a power to a power, let me just refresh that. Raise a power to a power. The rule is that you multiply exponents. Okay, so we're going to multiply these in. So it's pretty easy. This one, you just multiply that. It becomes 2 to the 2x equals, this one you have to multiply both of these in. So this becomes 2 to the negative x plus 3. Once these match, you can go ahead and just drop this exponent or this base completely, and we just set the exponents equal to each other. 2x equals negative x plus 3. If I add x to both sides, I have 3x equals 3. Divide 3 from both sides, and you get x equals 1. So when our x equals 1, this exponent should make these two sides equal. Let's really quick check that. So when we check that, 4 to the first power equals 1/2 to the 1 minus 3, right? So 4 to the first power is just 4. This is the same as 1/2 to the negative 2. If we put that in, it would be like 1/2 to the negative 2. That 1's also raised to negative 2, but it's still 1. So this would be the same as 4 to the 2 squared, which is 4 equals 4. Okay, so it works. Part B, I have 9 to the 2x equals 27 to the x minus 1. Hopefully you can see, okay, I want my base to be something that these have in common, and hopefully you can see what that will be. Oops, not 27. So I'm going to rewrite this base and leave the old exponents on the outside. So 9 is the same as 3 squared, and 27 is the same as 3 to the 3rd. I multiply these in then, so it's 3 to the 4x equals 3 to the 3x minus 3. Once these match, you can just drop these, so you have 4x equals 3x minus 3. If you subtract 3x from both sides, you get x equals negative 3. If I wanted to check that, some of these get pretty ugly, but our check here, you can always do these in your calculator pretty quickly. 2 times negative 3 is 27 times negative 3 minus 1. It's the same as 9 to the negative 6, which equals 7 to the negative 4. If we want to get rid of those negatives, 1/9 to the 6 equals 1/27 to the 4th. And here's where I would put it into my calculator. 9 to the 6th is 531,441, which equals 1/531,441. Okay, so it works out. Hopefully you're starting to see what we're doing here. Part C, again, I want to rewrite these two bases, but leave the exponents. So the simplest way to write 100 is 10 to the second. And the simplest way to write 1,000 is 10 to the third. If I multiply this in, this becomes 10 to the 14x plus 2. This becomes 10 to the 9x minus 6. These match now, so I can just drop them. So I have 14x plus 2 equals 9x minus 6. Isn't algebra amazing? So if you subtract 9x from both sides, you'd have 5x plus 2 equals negative 6. Subtract 2 from both sides, you get 5x equals negative 8. And then divide, and you get x equals negative 8 over 5. I will tell you this one does work, but boy is it ugly in your calculator. You can just type this whole thing in your calculator. So if you type in 100 raised to the 7 times negative 8 over 5 plus 1, and then you separately type in 1,000 raised to the 3 times negative 8 over 5 minus 2, you get this really ugly number, 3.98 times 10 to the negative 21, which equals another 3.98 times 10 to the negative 21. So I'm not saying they'll be pretty, but this is pretty straightforward. You just have to make those bases match. So it just comes down to breaking the base up, and if you set it up with those parentheses, you should be good to go. Remember, if you have any questions, you can email me, and I have office hours tomorrow, Wednesday, and Thursday.